Hello and welcome to the fourth video in the first chapter in Electromagnetism Chapter, Vector Algebra. In this video, we will do two examples on vector multiplication. So the first example is we have two vectors, vector A and vector B, and they want us to find the angle between vector A and vector B. Pause the video, try to solve it by yourself, and then come back to this video. From what we have learned in the last video, and if you recall correctly, there are two equations that involve the angle between two vectors in them. The first equation is the definition of dot multiplication. So dot multiplication, and it says A dot B will equal the magnitude of A multiplied by the magnitude of B multiplied by the cosine theta. And the second one is from cross multiplication. And it says A cross B equals magnitude of A multiplied by the magnitude of B multiplied by sine of theta. Yeah. We can use either of those equations to find the magnitude. We can find the angle theta. So I'm going to try to solve it with the dot multiplication and using the cross multiplication. So first of all, let's try the dot multiplication. Well, let's see what we have. Well, we have vector A and vector B, but what we need is the dot product between them, and we need the magnitude of both A and B. Well, we can find the magnitude, and we can find the dot product between both of them, and then we can use some basic algebra to find theta. But first of all, let's find the magnitude of both A and B. So the magnitude of A is equal to the square root of 3 squared plus 4 squared plus 1 squared, and that will be the square root of 26. And the magnitude of B is the square root of 2 squared plus 5 squared. 25 and 4, that will be 29. Now we need to find the dot product of A and B. So A dot B is equal to, well, 3 multiplied by the x component from B, the x component from A multiplied by the x component from B. Well, we don't have an x component from B, so it's 3 times 0 plus 4 times 2, the y components, plus the z components. So 1 multiplied by minus 5. 3 times 0 is 0. 4 times 2 is 8. 8 minus 5, and this will give us 3. Okay. And now we can say A dot B divided by the magnitude of A and the magnitude of B is equal to cosine theta, which equals to 0.1092, and the cosine inverse of 0.1092 will give us 83.72 degrees, and this is theta. Now let's do it in the cross multiplication to check if we'll get the same answer or not. Well, first of all, what we need to do is A cross B. So A cross B is equal to AX, AY, AZ. Then we write the components of the first vector. 3, 4, and 1. The components of the second vector, 0, 2, and -5. Let's write the answer here. Okay, so first of all, we open two parentheses and we write AX. If you do not know the steps of how to cross multiply or dot, I suggest you go back to the previous video, watch it through, and learn how to do it before coming here. Understand the basics of these multiplications. Now, as we said, we cross the AX horizontally and vertically, and then we go to the right and multiply the first component with what's diagonal to it, -5, minus the remaining components, 1 times 2, plus, we open two parentheses, AY. Then we erase all that. AY, AX. We reach AY, we cross AY horizontally and vertically and move to the right. We have 1. 1 multiplied by 0 minus the remaining components, 3 and -5. So we write 3 multiplied by 5, and the negative turn this to addition. Then we write plus. We erase all these, and then go to AZ and cross it horizontally and then vertically. And then we see what's right after it, and it's the number 3 multiplied by what's diagonal to it, that's 2 minus 4 times 0. We get 4 times -5, that's -20, minus 2 AX, plus 1 times 0, that's 0, plus 3 times 5, that is 15 AY, plus 3 times 2, well, that's 6, minus 0. AZ. Now we get minus 20 minus 2, so that's minus 22 AX plus 15 AY plus 6 AZ. So now we have A cross B, A and B, and we want to find sine theta, and we have the unit vector En. Now the unit vector En indicates the direction of the new vector. However, if we can find the magnitude of A cross B, we don't need this anymore since we're only comparing the magnitude of both sides. We don't need the direction anymore. So we can leave it out of the equation. The magnitude of A cross B is 22 squared plus 15 squared plus 6 squared. And this gives us the square root of 745. And now we can say sine theta is equal to the magnitude of A cross B divided by the magnitude of A and the magnitude of B. And this equals square root of 745 over the square root of 26 and the square root of 29, which gives us 0.994. And sine inverse of 0.994 is equal to 83.7 degrees, and this is theta. In case you did not understand what we have done in here, we said this cross multiplication logically says the magnitude multiplied by the direction is equal to the magnitude multiplied by the direction. And if we cross out the directions, we don't need them anymore and only focusing on the magnitude, we can say that the magnitude of A cross B is equal to the magnitude of A and the magnitude of B multiplied by the sine of theta, AB. That is essentially what we have done in this example. Hope you understood this. Let's now move on to the second question. So, the second example. We have three vectors, vector P, vector Q, and vector R. And we have 7 problems. The first one is find the value of P plus Q in parentheses plus multiplied by P minus Q. Second one is Q dot R cross P. The third one is P dot Q cross R. Fourth is sine theta QR. And the fifth one is P cross Q cross R. The sixth one is a unit vector perpendicular to both Q and R. And the seventh one is the component of P along Q. Pause the video, try to solve this by yourself, and then come back. So, the first one, P plus Q cross P minus Q. There's two ways to solve this problem. We can either use it the smart way, we can either solve it the smart way or straight up the mathematical way. The smart way is by using the properties of the cross product. And the straight up mathematical way is finding the value of p plus q and the value of p minus q and then cross multiply them. Well, first I'm going to start with the smart way by using the properties of the cross product. Well, luckily, one of the properties of the cross product is that we can distribute the cross product inside the parentheses. So we will distribute p plus q. We will distribute these vectors onto this parentheses. So we will have p cross p minus q plus q cross, p minus q. Now, again, we will use the distribution property to distribute p into p minus q and q into p minus q. So we will get p cross p minus p cross q plus q cross p minus q cross q. Now, if you remember all of the properties, one of them said if we cross multiply a vector by itself, the result will be 0. And here we have p cross multiplied by itself. So the answer to this will be 0. So we can just cross it out. We have minus q and q. We can cross this out too. So we are left with p cross q plus q cross p. Now, minus p cross q and q cross p. If you remember the first property in the cross multiplication is that the cross multiplication is not commutative. However, it is anti-commutative. So q cross p does equal to minus p cross q. So we can say all of this is equal to 2 q cross p. And now we can only find the value of q cross p and then multiply it by 2, and that is a much faster way than doing all of straight up mathematically. So let's find the value of q cross p. So q cross p is equal to ax, ay, az. The first vector is q, so we put the components of q first. We do 2 minus 1, 2. We got the components from here. And then we put the components of p, which are 2, 0, and minus 1. And then we close it. We open a parenthesis and write ax. We find ax, we cross it horizontally and vertically. And then move on to the next component, which is minus 1. So we say minus 1 multiplied by minus 1, we multiply this and this together. And we get 1. I'm gonna not write everything in here. And then we have 2 times 0, we get minus 0, AX, plus, we erase all of the extra stuff. Okay, now we have two parentheses. We find AY and we write AY here. We cross AY horizontally and vertically, and then we move on to the right and we have 2. And then we multiply it diagonally with the other components. So it's 2 times 2 minus 2 minus 1. So that is plus 2 times 1 plus, we open two parentheses. So we delete these. And then we say AZ, we find AZ, we cross it horizontally and vertically, and we move on to the right, which is 2. And then we multiply it diagonally, which is 2 times 0 multiplied by minus 1 times 2 minus plus 1 times 2. And this is equal to 1 minus 0 is AX. Plus 2 times 2 is 4, plus 2 times 1 is 2, so plus 6AY plus 2 times 0 is 0, plus 2AZ. And don't forget we have the 2 here, so we multiply all of this by 2, and we get 2AX plus 12AY plus 4AZ. And that is the final answer. Now let's do it straight up mathematically in this region. So P plus Q, P plus Q is equal to 2 plus 2 AX plus the Y. P doesn't have any Y components, so 0 plus minus 1 AY plus the Z components minus 1 plus 2. A Z, which gives us 4 AX plus the minus AY plus 2 1 AZ, and P minus Q is equal to 2 minus 2 AX plus 0 minus 1, which is plus 1 AY plus minus 1 minus 2 AZ. And we get 0AX plus 1 AY minus 3AZ. And now we cross multiply them together. This cross multiply this, but this one's first. So we write ax, ay, az, 4 minus 1, 1, 0, 1 minus 3 is equal to minus 1 cross multiplied by minus 3, that is 3, and 1 cross multiplied by 1, that is 1, so minus 1, ax, plus ay, 4 multiplied by minus 3, that is minus 12, minus 1 multiplied by 0. Oh, I did the opposite. I did a mistake. It is 1 multiplied by 0, 0 minus plus 12. A y plus az, we have 4 multiplied by 1, that is 4 minus 1 multiplied by 0, 0 az. And we have 3 minus 1 is 2ax plus 12ay plus 4az, which is exactly the same. And now we can say that both our answers are correct. B, we want to find Q dot R cross P. Well, again, there is two ways to solve this example. One is the smart way, which is by using the triple scalar product rule. And the second way is straight up mathematical way. I'm gonna start with the smart way, just like before. So Q dot RP, if you recall, we can do it as the components of Qx, Qy, Qz, and the components of Rx, Ry, Rz, and the components of Px, Py, Pz, and do it just like cross multiplication. That's the smart way to solve. And I'm gonna do it that way at first. So let's do it a little bit lower in here and have a 3. So Q, we have 2ax minus 1, that's minus 1, and 2. Then we have the R, which is 2 minus 3 and 1. And then we have 2, 0, minus 1. Luckily, all the components of x are 2. So we open two parentheses, put 2 in here, and then just like the cross multiplication, we multiply these two together and these two together. This is minus 1. So minus 3 minus 1, that is 3 minus 1 multiplied by 0, 0, plus, bring the eraser, we erase these lines and say, we open a second parenthesis, we write -1 in here, and then we cross it horizontally and vertically, and then we find 1 and cross multiply it by 2. So 1 multiplied by 2, that is 2, and 2 multiplied by 1 by -1, so that's minus plus 2 plus, open the parentheses, erase the lines, and then write 2 here, which is this one, and then cross it horizontally, vertically move on to the right, and we have 2 multiply it by what's diagonal to it. So 2 times 0, that's 2 times 0 is 0, and -3 minus 2, it's -6, but there's already subtraction here, so it becomes plus 6 multiplied by 2. And this will equal to 3 minus 0 is 3 multiplied by 2, which is 6, plus 2 plus 2 is 4, minus 1, that's minus 4, plus 0 plus 6 multiplied by 2, and that gives us plus 12. And this equals to 6 minus 4, that is 2, it will give us 14. Now let's do it the straight up mathematical way. Let's see if it has the same answer, and then I'm going to give you a secret solution. It's a little bit faster. So let's draw a line. And write here 3 cross P, which equals to R. You write AX, AY, and AZ. Don't forget that this is a normal cross multiplication. And we write 2 minus 3 plus 1. We have the R first, so we write the components of the vector R first. And now we move on to vector P. 2 minus 2, 0 minus 1. And then we solve this multiplication. We open 2 parentheses, we write AX. Minus 3 multiplied by minus 1, that will give us 3. Minus 1 plus multiplied by 0 gives us 0. Oh, there's a mistake. That's P. Oh, no mistake. So, plus have 2 parentheses, AY, and then we have 1 multiplied by 2, and that is 2. We have minus 2 multiplied by -1, we have minus 2, and then it becomes plus 2. Plus 2 parentheses, AZ. AZ, and now we have 2 times 0, which is 0, minus plus 6. And then we say 3AX plus 4AY plus 6AZ. Now we dot product Q dot this new vector 3AX plus 4AY y plus 6az. Let's see if it has the same answer. Well, it's as simple as q 3 times 2, 3 times 2, ax plus 4. Oh, there's no ax. Don't forget this is dot multiplication. There's no unit vectors. 4 multiplied by minus 1, so that's 4 multiplied by minus 1, plus 6 multiplied by 2, which is 12. 3 times 2 is 6, plus minus 4, plus 12, 2, that will give us 14, which is the same answer as this. And now we know that our answer is correct with both different ways. And that is the beauty of math. If you forgot the principle, if you forgot the shortcut, you can just do it the long way and you will get the answer. Now, I want to introduce to you, I don't want to say a life hack, but it will make things easier when for you when you do the triple scalar product, and it also works for the cross product. So I'm gonna use it for this one. So let's say you want to find the value of the triple scalar product. I mean the triple scalar product. You have 2 minus 1 and 2. Let me remove these. You also have 2 minus 3 and 1, 2, 0, minus 1. And what you do now, usually you stop at this point. But this secret way, it's not a secret way, it tells you repeat the first 2 rows. So you say 2 minus 1, 2, 2 minus 3 minus 1. And then you write, then you draw a diagonal line. Let me use this color. You write this line like this, and the second line, you draw it properly, and then you draw a third line. The line have to cross the components, not just normal lines. You cross -2, 3, and 2. With the second line, cross 1, 0, and 2, and with the third line, you cross -1, -1, and 2, and then you write subtract. And then you write, then we draw additional 2 lines, but now it's from left to the right. 2 minus 3 minus 1 plus 2, 0, 2 plus 2 minus 1 minus 1 plus the ones that are from left to right, I'm sorry, from right to left, these we draw with the subtraction symbol, and the ones from left to right we draw addition next to it, and then we write. Now you multiply the lines, the components that are inside the line. So we multiply 2 minus 3 and minus 1. We write 2 times minus 3 times minus 1. And the addition sign is the symbol of the parentheses. Then we move on to the next one. Plus, plus, parentheses, 202 times 0 times 2 plus 2 times 1 times minus 1 minus, now we move on to the next line, minus, see I drew here a negative sign, 2 minus 3 and 2, so 2 times minus 3 times 2 minus 1 times 0 times 2, so 1 times 0 times 2, sorry, minus 1 minus 1 times 2, so minus 1 times minus 1 times 2, and then you multiply and add them together and you will get the same answer. So 2 times 3, that is negative 6, times negative 1, that is 6, plus 0, plus 2 times 1 times negative 1 times negative 1, that is just 2, minus 2 times 2 is 4 times negative 3, that is negative 12, but there is already a negative sign, it becomes plus 12, minus 0, minus 1 times minus 1, that is 1 times 2, so minus 2. And this will equal to 6 plus 2, 6 plus 2 is 8, plus 12, that is 20 minus 2. Ooh, this is not minus 1, this is plus 1. Okay, so the third one, so this is plus 1, so this is minus 2. So 6, 4, so these two cross. I don't know how to do basic math. 6 minus 2 is 4. Minus 2 is 2. Plus 12, that is 14. So we had one mistake, but we solved it, and the answer is also 14, which is the same 14 here, which is the same as this 14. And it is faster if you do things inside your head. I had to break every step down just so you can understand it, but you can do this as a faster method if you know how to calculate things fast inside your head. All three methods are correct. You can also use this for cross multiplication. It doesn't have to do with triple scalar product. But I believe that the normal cross multiplication is easier for the brain because there are variables which are the unit vectors. It's easier for the unit vectors. But if it's just numbers, you can use this shortcut method. I don't know the name of this method, but it is faster than doing this, and it makes much more sense inside the head. C. They want us to find P dot Q cross R, which is again a triple scalar product. This question is just to prove the property that if you change the order for the triple scalar product, it will give you the same result. But I'm gonna use this to solve the last shortcut method and try to make you understand it better. The answer will be 14 if you're in an exam or in a homework or whatever, wherever you are using this, just write 14 and move on. Don't waste your time. But if you're trying to practice, this is for you. We draw a line and then we write the components of P, which are 2, 0, minus 1. Be careful that it has no y component. You can write it as 2ax plus 0 ay minus az to make things easier for you. Don't put minus 1, 0. Don't write it as 2, 0, sorry, 2 minus 1, 0. This is incorrect. So, 2, 0 minus 1. Cube. 2 minus 1, 2. 2 minus 3, 1. And then we rewrite the first row. 2, 0 minus 1. And then the second row, 2 minus 1, 2. Don't do my mistake. Be careful of the components you're trying to copy. We go from left to right. That's how we start. We cross diagonal the components starting from the top. I'm gonna try to use steady lines. Maybe that will help. So minus 1 and 1, minus 3 and minus 1, 2, 0 and 2, minus 1 and 2, 2, 3, 2, 1, 0, 1, 0, 2. I know the lines right now are very wiggly, but on paper it should seem more organized. So the ones that are from left to right, we write a plus sign next to them, and the ones that are from right to left, we write minus next to them. Now let's see. 2 times 1 times 0 times 1, that is minus 2, plus, because there's an additional sign here, 2 minus 3 minus 1, that is 2 times minus 3 minus 6 minus 1, and that is 6, plus 0 because it is multiplied by 0, minus 1 minus 1, 2, 2, and then there's a negative, minus 2 minus 3 and 2, 2 and 2, 4 minus 3, that is 12. And there is a negative sign from the negative 3. And now 1 times 0 times 2, that is 0. And now we add them all together. Minus 2 and 6, that is 4. Plus 0, still 4. Minus 2, that is 2. Minus 12, that gives us 14. And the answer is correct. It should give us 14. D. They want us to find sine theta q r. Well, you either find theta q r and then plug it in like we did last example. But why should you find theta and then plug it in? What already has sine theta in it? Well, as you may know, the definition of cross multiplication is the magnitude of the first multiplied by the magnitude of the second multiplied by sine theta multiplied by the unit vector. So what we can do is that, say, q cross r is equal to magnitude of q magnitude of r sine theta QR AN, or I'm just gonna remove AN and write the magnitude of QR. Now we need to find Q cross R. Let's do it over here. Right, AX, AY, AZ. And then what's the components of Q? 2 minus 1, 2, and the components of R are 2 minus 3 and 1, and then we close it down. We open a parenthesis and say AX. We cross it horizontally and vertically, and then we multiply minus 1 and 1. That gives us minus 1. Minus 2 and negative 3, that is negative 6 plus 6. Plus, we remove the lines, and then we cross AY. Close the parentheses and write AY. We move on to the next one. To the right, it is 2. 2 times 2, that is 4. Minus 2 times 1, that is 2. Plus, 2 parentheses, AZ, and then we close, and then we erase these lines. AZ, we cross it vertically and then horizontally. Horizontally, and then vertically. And then we go onto the next one, which is 2. 2 times minus 3, that is minus 6. Minus 1 times 2, that is plus 2. And now we get minus 1 plus 6, that is 5 AZ. AZ, 5 AX, plus 4 minus 2, that is 2 AY, plus minus 4 AZ. And now we find the magnitude. We say 5 squared plus 2 squared plus 4 squared, which gives us the square root of 3 multiplied by the square root of 5. And now we find the magnitude of Q. Magnitude of Q is the square root of 2 squared plus 1 squared plus 2 squared, which gives us 4, and for 8 square root of 9, that gives us 3. And the magnitude of R is equal to 2 squared plus 3 squared plus 1 squared, which gives us 9, 13 square roots of 14. And then say sine theta is equal to 3 square root of 5 divided by 3 square root of 14. 3 and the 3's go. The answer is 0.5976. And then we find the inverse of 0.5976. We get theta is equal to, oh, I'm sorry. That's what we need. We need to find theta. So, and that is the answer, 0.596. There you have it. Okay, so now E. Find the value of P cross Q cross R. Well, this is a triple vector product. We can either follow the vector triple product rule, or we can solve it mathematically by breaking it apart. Well, first I'm gonna try solving it by the vector triple product rule, which is back cap, if you remember, which was B multiplied by A dot C minus C A dot B. So it will go as B in this case is Q, and this is A, and this is C. So it will be Q multiplied by P dot R minus R multiplied by P dot Q. Let's erase this. And let's start solving. So here, let's do P dot R. So that's just as multiplying the components, the like components together. So 2 times 2, which are the x components, plus 0 times minus 3, 0 times minus 3, plus minus 1 times 1, which will be 4 plus 0 minus 1 equal to 3. And now we need to do P dot Q. So P dot Q, 2 times 2 plus y, there's no y, so 0 times 1 minus 1, plus z minus 1 times 2. And this will give us 4 minus 2 is equal to 2. And now we say Q times 2 minus R, I'm sorry, Q times 3, which is P dot R, times R minus R times 2. Now Q times 3, we just multiply the Q values by 3. So Q times 3, we just multiply Q by 3. So 2 times 3, that is 6AX, minus 3 times minus 1, that is minus 3AY, plus 3 times 2, 6AZ. Minus the R multiplied by 2. So 2 times 2, that is 4AX, minus 2 times 3, that is 6AY, plus 2 times 1, that is 2AZ. And then we close it. And now we subtract 6 minus 4, that is 2AX, minus 3 minus 6, so that's 3 plus 6, So we get plus 3ay, and 6 minus 2, we get plus 4az, and that is the um, final vector, final product. And it is a vector because it's a triple vector product. That's how you know your answer is correct. Now, the second way to solve this is by directly multiplying the vectors. So we will say, we'll start with Q. We'll start with Q cross R. And we already have done that above, and we know that the answer is 5ax plus 2ay minus 4az. Luckily, we have that figured out. And now we need to cross multiply this with Q. So P cross this will give us ax, ay, az. And then we will write the components of P first, which are 2, 0, minus 1. 2, 2, 0, minus 1. And here we write 5, 2, minus 4. And then we close it. So we open a parenthesis and we write ax. 0 times minus 4 is 0. So minus 1 minus 2, and that will give us 2 plus. We have minus 1 times 5, so that's minus 5. Minus 2 minus 4, so that will give us plus 8 ay plus 5 times 2, that is 4, minus 0 az, and this will be 2ax plus minus 5 plus 8, that is 3ay plus 4az, and that is the same. And now we know that our answer is correct. Now F, a unit vector that is perpendicular to both Q and R. What is something? When we do them together, we get a perpendicular answer, cross multiplication. So we need to cross Q and R and find the unit vector of that answer. So let's get into it. Q cross R. ax, ay, az, and then we close it. Q, we start by the components of Q because it is the first vector. We write 2, minus 1, and 2. And then the components of R, we write 2, minus 3, and 1. We open two parentheses and we write ax, and then we cross ax horizontally and vertically, and then we move on to the next component, which is minus 1, then multiply it by the diagonal vector. Minus 1 times minus 1, minus 1 times minus 1, minus this component multiplied by minus 3. So 2 times minus 3, that is minus 6 plus 6. Plus, remove the lines so we can see better. Then close the parentheses and write AY. We cross AY horizontally, vertically, move on to the next vector, which is 2. And then multiply by the diagonal vector. So 2 times 2 minus the rest component, 2 times 1. And then we delete the length. By now, you should be getting it faster, and you should understand the whole steps by now. AZ, we cross it vertically, horizontally, and then we move on to the next vector, which is 2. And then we multiply it by the diagonal vector. 2 times minus 3, that is minus 6. Minus 1 multiplied by 2, which is plus 2. And now 1, that is 1 plus 6, give us 7ax. This is plus 1. So this should give us 5. Plus 2 times 2, that is 4, minus 2, that is 2ay, plus minus 6 plus 2, that should be minus 4az. And now we need to find the unit vector of this vector. The unit vector for anything, let's vector A, is the vector divided by the magnitude of that vector. So the magnitude of this vector is 5 squared plus 2 squared plus 4 squared. 5 squared plus 2 squared plus 4 squared, 25 plus 16 plus 4, that is 45, the square root of 45. So we write 5ax plus 2ay minus 4az divided by the square root of 45. And this gives us 0.745ax plus 0.298ay plus, minus 0.596az. That is a unit vector that is perpendicular to both Q and R. For G, the component of P along Q. And if you remember, to find the component of a vector along another vector, we just multiply the vector that we want to find the component of, which in this case is P, dot product by the unit vector of the direction of the vector that we want to find, which is in this case a q. And now we need to find the value of a q. To find the value of a q, we need the vector q and the magnitude of q. We have already found the magnitude of q, which was 3 above. The question G wants us to find the component as a vector. And if you remember how to vectorize this value, we just multiply it by a q again. So this becomes p dot q divided by the magnitude of q multiplied by q, the vector, divided by the magnitude of q. So this becomes q divided by the magnitude squared multiplied by p dot q. And to find p dot q is much easier than just substituting the unit vector. You can do that and you will get the correct answer. So p dot q is 2 times 2, which is 4, plus 0, because we don't have a y component for p, plus minus 1 times 2, which gives us 4 minus 2, 2. We have already done that above. And now we can write it as 2q divided by 9, magnitude squared, and the magnitude is 3, so 3 squared is 9. You can just substitute the vector and multiply by 2 and then divide by 9. And the answer will be 0.444ax minus 0.222 ay plus 0.444az, and that is the component of p along q. I know this video was longer than the usual videos, and I hope you stayed focused until the end. I know it was a lot of calculations, but I hope you understood everything in this video. And if you solved all of this by yourself, give yourself a big clap because you deserve it. And that's the end of chapter 1 as the chapter goes in the book. In the future, I might add another examples to solve as the time goes, but for now, this will be enough. And good luck in chapter 2.